Hello guys, I am Engineer Jewel Ryan Nicole Biriosa, and today I will be discussing overview of thermodynamics. So this will be our lesson number one for our thermodynamics. So today I will be giving you overview, meaning I am giving fundamentals, basic of thermodynamics. Actually, I think you will be hearing terms related to thermodynamics na hindi nyo akala related to thermodynamics. So probably alam nyo na siya dati, but then hindi nyo nga alam na related siya sa thermodynamics. So let's start. So guys, here we have learning objectives. Of course, we always need to have objectives kasi we have goals, right? So dapat ma-emphasize natin or ma-specify natin kung ano yung gusto nating mangyari at the end of the day. For example, today I really wanted to record a good video, but then ang goal ko talaga is mahanap ko yung time wherein hindi masyadong tumitilak yung mga manok. So, but then, feeling ko naririnig nyo ang aming mga mahal na manok. So, it's part of our life. So, ginawa ko na ang lahat, renovate my room, and then, andito na ako sa kasulok-sulukan ng kwarto ko just to eliminate noise. But then, I think that's the best I can give. So, I'll be trying next time. I'll be trying my best and more next time. So hopefully, makisama na ang mga manok. So, kidding aside or being serious, so our learning objectives for this module or for this overview of thermodynamics is to understand basic principles and concept of thermodynamics. As I have said earlier, our main goal, or I will be introducing to you basic principles and concept of thermodynamics. So you'll discover it later on. And then recognize different terms with respect to thermodynamics. As I have said earlier also, meron ditong mga terms na narinig nyo na dati, and then you will be realizing na, it's related to thermodynamics pala. And then identify the different properties of substances. So we'll be enumerating and discussing it. So let's proceed na. So first of all, I will be introducing to you key terms in thermodynamics. So, well, of course, first, what is thermodynamics? For those who haven't heard of this or don't know the meaning, thermodynamics can be related to the study, or it is the study of heat and work. So you'll be hearing a lot of heat and work in thermodynamics. And then pure substance is a working substance whose chemical composition does not change or remains the same even if there's a change in phase. So, ulitin ko, pure substance is a substance whose chemical composition remains the same even if there is a change in phase. So, ideal gas. Ideal gas is a working substance which remains in gaseous state during its operating cycle. And usually, if you heard the equation PV is equal to MRT, or I think in chemistry, it's PV is equal to nRT, we are talking about ideal gas. So I hope I already give you some background or some brief definition of the important terms in thermodynamics. So let's go to the next slide. So I will tell you about something related to, or what is the relationship of thermodynamics and energy. So the etymology of the word thermodynamics is therme and dynamis. So therme means heat, and dynamis is related to heat and power also. And then, so there are some definition also of thermodynamics, which is science of energy. It is purely related to energy, of course. And then energy can be viewed as the ability to cause changes. And then thermodynamics as a science of energy is the science in which it concerns in the storage, transformation, and the transfer of energy. So next slide. Speaking of energy, energy can be internal energy, kinetic energy, potential energy, and then chemical energy. So this is transformed from one species to another. So I think you probably heard about energy transformation. Energy can neither be created nor destroyed, and we will be talking about it. I will be creating a video about laws of thermodynamics, but then I will be giving you now a brief overview of what is the conservation of energy. So, one of the most fundamental laws of nature is the conservation of energy principle. It simply states that during an interaction, energy can change from one form to another. I'll repeat, energy can change from one form to another, but the total amount of energy remains constant. So, energy can change from one form to another, but the total amount of energy remains constant. Okay? That is, energy cannot be created nor destroyed. Okay? So, thermodynamics and control volume. In many cases, a volume in space into which a substance flow is called a control volume, or it can be a pump, a turbine, an inflating balloon. They are examples of control volume because, as defined, it is a volume in space into which a substance is flow or substance is flowing. The surface that completely surrounds the controlled volume is called controlled surface. So, surface that completely surrounds the controlled volume, of course, is termed as controlled surface or control surface. Properties of working substances is, I think, the highlight of this video because for me, as a math lover myself, I really prefer those topics with formulas, with problem solving. So here I will be sharing to you concepts and then formulas and some tips on how to solve problems related to the properties of working substances. So first, let us define those properties referred to. So what are those properties? So we have here pressure and temperature. So pressure is defined as the ratio of force per unit area. So we have here the two of the most common terms for pressure. We have gauge pressure, vacuum pressure, and the other one is atmospheric pressure, which is actually related to both the gauge and vacuum pressure. So gauge pressure is the pressure reading from the gauge pressure instrument. So that's why it is called gauge pressure. So it can be higher or lower than the atmospheric pressure. And then we have the vacuum pressure, which is a pressure that is less than the atmospheric pressure. So the relationship of gauge pressure with respect to the atmospheric pressure is it can either be higher or lower than the atmospheric pressure. But then vacuum pressure, in terms of atmospheric pressure, in simpler terms, atmospheric pressure is always higher than the vacuum pressure. So next, temperature. Temperature is the degree of hotness and coldness of a substance or body. So we have two measuring instruments here, the thermometer and pyrometer. So thermometer is simply the instrument used to measure the temperature of a body or a substance. So pyrometer is an instrument also used to measure high temperature gases. So this is my favorite part, the formulas part. So first we have the pressure. So as defined, pressure is the force over area. So our sample units here. So upon encountering pressure, this is the possible units that may appear. So, for example, kilonewton is a unit of force, and then meter square or square meter is a unit of area. So, meaning kilonewton per meter squared is a unit for pressure. And then kilonewton per meter squared is equal to kilopascal. And then we have here pound, which is a unit of force, pound force. And then unit of area is inches squared. So, kilonewton per meter squared or Pascal or kilopascal is an SI unit. And then pound per inches squared or what we call PSI is an English unit. And then, of course, we have here the absolute pressure, another term for another kind of pressure aside from gauge, vacuum, and atmospheric pressure, which is not mentioned earlier. So we have here absolute pressure, which is the gauge pressure plus the atmospheric pressure. So here is the formula. So it's P absolute is equal to P gauge plus atmospheric pressure. And then we also have another pressure, which is the hydrostatic pressure. This is the formula is equal to the density of the fluid times the height of the fluid. The symbol used for density here is an italicized small letter W. Other books have D, small letter D, and then symbol rho, it's like an italicized P. So, don't be confused, basta you know that the formula for hydrostatic pressure is density of the fluid times multiplied by the height of the fluid. And then, so we have here also the conversion. Conversions is very important because there are some given in which, for example, we have here our final answer is in atmospheric pressure, which is in ATM, but then the question is asking for the final answer for PSI, inch HG, mmHg. So we need to know the different units, the different conversions, because most especially in board exams or in exams that you will take in the future, you need to memorize, you need to know this. Primarily because it is very important. We should not always think of one unit only as a unit only kasi siya yung common dito sa Pinas. English unit is for US only or for the English Republic or English people who are using the English unit. But then, I think it's really important because we really don't know in the future if we'll be going as engineers, as architects, or different field. We really don't know if we'll be staying in the Philippines forever or we'll be having our career here. So, we must know what are those units. And then, and of course, in calculator, nakalagay din naman sa calculator yung mga conversions na yan. Hindi naman siya nilagay dyan kung wala siyang purpose. So, yun lang for the pressure. So, now we have formulas for temperature. So, temperature, we have here relation between degree Celsius and degree Fahrenheit scale. So, this is important to know, most especially if I don't want to use calculators, or as a professor, I don't usually allow my students to depend on calculators. So, you should know the relationship between degree Celsius and degree Fahrenheit scales. Why? Because this is your key to other absolute temperature. So we have here absolute temperature Kelvin, and then we have here absolute temperature Rankine. For Kelvin, the degree Celsius plus 273. Other books are using 273.15, but in my case, I'm allowing to use 273 only for uniformity, so for the final answers of my students to be uniform. Others are using 273.15. I want to avoid that 273, and then others have 273.15, so that after all of the solutions we arrive at same answers. And then for Rankine, we have degree Fahrenheit plus 460. So what I have said earlier, Celsius is related to Kelvin, and then Fahrenheit is related to Rankine. So meaning, if you know the relationship between the degree Celsius and degree Fahrenheit, you will know the you can connect the relationship of Kelvin to Celsius, and then Rankine, Kelvin to Fahrenheit, and then Celsius to Rankine. So that's why you need to know this. And of course, thermodynamics is about there are a lot of temperatures that we will be talking about in thermodynamics. So this is very important. So we have here the density, which is M over V, which is mass over volume. M is mass, and then the big letter V is volume. The small letter B, which is italicized, it is specific volume, and then SG is specific gravity. It is a must also that we know what are the different units for mass, which is kilograms, pounds. These are the most famous units. And then for volume, we have meter cube, feet cube, inch cube, cm cube, specific volume. So for having specific volume, we really need to know the specific units in which they are SI unit. For SI unit, we have meter cube per kilogram, and then for English unit, we have feet cube per pound. And then specific gravity is density of any fluid over density of water. So that's how we solve that. And then if two fluids are mixed, so we're talking about mixture now, the mass of the first fluid plus the mass of the second fluid all over the volume of the first fluid plus the volume of the second fluid. So that's how we solve the density of the mixture. So for the specific volume of the mixture, we only need to reciprocate it, because density is the reciprocal of the specific volume. And then for flow work, we have here the pressure and the specific volume. So sometimes we can use also the volume, but if we use the volume, our formula will only be the final unit is in kilojoule, and then if we use the specific volume multiplied by the pressure, which is kilonewton per meter squared, or what we call kilopascal, it is in kilojoule per kilogram. So you have to note the given, if the given is volume or the specific volume. If you find it hard to use the big letter V and the small letter v, you can use any notation as long as makakatulong yun sa inyo. As long as alam niyo yung concept na flow work is equal to pressure times specific volume. If you want the specific volume to be SV, SPV, or you want the whole word, you can write it as on your solution. I think it's okay lang naman. So here we have enthalpy and entropy. And there under enthalpy, we have stagnation enthalpy. But then the usual enthalpy formula used is this, the internal energy plus flow work. So I've already discussed the flow work earlier, in which it can be pressure times the specific volume, or pressure times the volume itself. But then, internal energy is in kilojoule per kilogram. So, if you are solving for enthalpy, make sure that the flow work is also in kilojoule per kilogram. Meaning, you have to use the specific volume. But then again, you have to consider the given. So, you have to consider the unit of the given, or the unit which is asked in the problem. For example, your final answer is in kilojoule per kilogram, but then I want it to be in what are the I want this in English unit. English unit is BTU per pound. So you should know the relationship between kilojoule and BTU, or kilogram and pound. So that's the essence of conversion. That's why, simula pa lang, paulit-ulit ko na sinasabi ang halaga ng conversions. So for stagnation enthalpy, this is an empirical formula wherein you just have to know, if the problem states that it is asking for stagnation enthalpy, you will be using this formula for enthalpy, wherein VO is initial velocity and HO is ordinary enthalpy, or the enthalpy, which is internal energy plus flow work. And then we have your entropy. Entropy is equal to heat over temperature. That's how simple it is. Q over T. So this is the last set of formulas for our overview of thermodynamics. This is the general flow equations. So we have the terms here, the volume flow rate and the mass flow rate. Of course, for the volume flow rate, we have here volume, which is usually in meter cube, feet cube, inch cube, over time, which is in second. But then again, our time can be in hour, minute, second, days. So it is depending upon depending on what is asked on the problem. So we have here the volume flow rate, Q is equal to area times velocity. So usually, if our area is meter squared, our velocity is in meter per second, we will be arriving at a final unit, which is meter cube per second. And then we have mass flow rate, which is Q over V, and then Q is volume flow rate, and then our small italicized letter V is specific volume. So what we will be having here is kilogram per second. We also have area times velocity over a specific volume, that will also be in kilogram per second. And then we also have here area times velocity times density, which is equal to kilogram per second. Sabi ko nga kanina, this is the part wherein this is what I want, problem solving. So, let's go. Sample problems na agad. So, convert 750 Rankine to Kelvin. So, tips in solving problems. First of all, you should always write the given. So, we have here 750 Rankine. And then, of course, the required. So, the required is yung 750 Rankine should be converted to Kelvin. So, we have, I think, the most comprehensive solution here is 3 steps. We need 3 steps here. So, first, 750 Rankine to Fahrenheit, to convert it to Fahrenheit. That's our direct relationship, right? The Rankine to Fahrenheit. And then, after arriving to Fahrenheit, we have Fahrenheit to Celsius. And then, after arriving to Celsius, we have the direct formula from Celsius to Kelvin. So, from 750 Rankine to Fahrenheit. So, a temperature in Fahrenheit plus 460 is equal to a temperature in Rankine. So, meaning, we need the Fahrenheit plus 460, which is equal to the given 750. So, we can get the Fahrenheit by transposing 460 to the other side. So, 750 minus 460 is equal to 290 degree Fahrenheit. So, we now have the 290 degree Fahrenheit. And then we now convert it to Celsius directly from our calculator, since we have here beside us. So, the conversion is easy depending upon also on the use of your calculator. So, another tip, love your calculator. So, here's my calculator. I use this in the board exams. So, Casio FX570S Plus. And then, know where's the conversion panel. And then, probably memorize it. Because when I allow my students to use calculator, I don't usually allow them to have their covers. This is prone to cheating. And then we have here Celsius to Kelvin. So, temperature in Celsius plus 273 is equal to Kelvin, meaning our 143.33333 degrees Celsius plus 273 is equal to the final answer, 416.333333 Kelvin. Also, another note, as much as possible, do not round off your answers into 2 decimal places, 4 decimal places, as long as it is not the final answer, for the uniformity of answers also. So that's only a tip. So next problem. If you have questions, you can message me or you can comment down here, or I will be providing my personal Gmail account if you want the copy of my modules or this PowerPoint presentation. So next problem. Steam flows through a nozzle at 400 degrees Celsius and at 1 megapascal. At this temperature, the enthalpy is 3,263.9 kilojoule per kilogram with velocity of 300 meters per second. Find the stagnation enthalpy. So, of course, given we have enthalpy and then velocity, I did not include the 400 degrees Celsius and 1 megapascal because the required is stagnation enthalpy. And the formula for stagnation enthalpy is we only need the original enthalpy HO and the velocity. That's why I only write the given, which can be used in the formula. So, since the stagnation enthalpy has an empirical formula, so we can now substitute the given into our formula. So, we have here the final answer, 3,308.9 kilojoule per kilogram. So, yan. If you wish to have a copy of this PowerPoint presentation, the complete module of this overview of thermodynamics, kindly email me at ryannicole05@gmail.com. Thank you. See you on my next videos.